Taking a look at 9.7, dealing with we'll get into our final transformation, your dilation. But before we do, just a quick reminder. First off, this is the type of composite transformation you can expect to see on your chapter test. Right? It says segment AB has the coordinates that are there. First, it wants us to rotate that figure 90 degrees 90 degrees clockwise, and then translate it 2 units right and 1 unit up. We did not learn any type of rules for clockwise rotations. We said instead we were going to convert it to counterclockwise. So 90 degrees clockwise is actually 270 degrees counterclockwise. So taking a look then, taking that point A, 270 degrees counterclockwise. We're starting with 1, 3. If I go 90 degrees, we flip it. Change the sign of my new X. Go another 90 degrees. We flip it. Change the sign of the new X. To go my 270 then, we'll flip it one more time. Change the sign of the new X. So for B, we're going to do the same thing. We started with 3, 6. We flip it. Change the sign of the new X. Flip it. Change the sign of the new X. And finally flip it one more time. Change the sign of the new X. So my my A prime was at 3, -1. And B prime is at 6, 3. From there, it says to translate it 2 units right and 1 unit up. So that means that we are going to add 2 to our X value and add 1 to our Y value. So our A double prime then is going to be at 5, 0. And B double prime is going to be at 8, -2. Right? And then this is what you are going to be graded on come time for that chapter test. All right, our last transformation is what is known as a dilation. To do a dilation, essentially all we're going to be doing is scalar multiplication. Scalar multiplication is the process of multiplying each element of a matrix by some real number. So here we multiply everything by 2. Right, we've dealt with dilations before. Typically, they'd show you a problem like this, and you look at that dilation, and you say, okay, I had to take 2 times 3 to get 6. So I'm going to take 4 times 3, and I'm going to say that X is 12. That dilation is a transformation that is going to stretch or shrink a figure to create some new similar figure. A dilation can increase the size, or it could decrease the size. A decrease in size is known as a reduction, a dilation by a scale factor that is between 0 and 1, something like 1/2 or 3/4 or 0.5 if you want to use a decimal. Or you could have an enlargement, a dilation by a scale factor that is larger than 1, something like the scale factor of 2 or 3.5 or 7/3. Now, typically, people will look at this problem and say, okay, it's a dilation, and I'm going to go 2 to 6 and multiply by 3. But we need to be careful. Remember, there are new figures and old figures. Our new figure is the A prime, B prime, C prime. The old figure is the A, B, and C. So our figure did not get bigger. It actually got smaller. So instead of having a scale factor of 3, it actually has a scale factor of 1/3. One easy way to make sure we talk about that scale factor in the right order is we always put new on top and old on the bottom. So here, if we look at our figure, our scale factor would be 4/8, which is 1/2. Which, when you look at it, that is why this is a reduction in this case, since our figure got smaller in size. So it says find the scale factor of your dilation, then tell whether it is a reduction or an enlargement. So we have two segments here. We have C to P, which is right here, and C to P is 6. And then we have our C to P prime, which is the longer segment that's here, which is 10. So to find your scale factor, it is new over old, so it is 10 over 6. And then just like we do with all of our fractions, we reduce it. So we get a scale factor of 5/3, which would make it an enlargement. Looking at our second one then, it says find our scale factor. So now my C to P, my C to P is 22. My C to P prime is 11. So new over old for your scale factor, it is 11 over 22, which reduces to 1/2, which would make it a reduction. So it says draw and label parallelogram LMNP, then construct a dilation centered or with point L as the center of the dilation and a scale factor of 1/2. What this means is everything is going to get pulled back towards L by a scale factor of 1/2. So if L to M is 8, L to M prime is now 4. If L to P went down 8 and left 2, it now only goes down 4 and left 1. Same thing with N. If L to N went over 6 and down 6, now it's going to go over 3 and down 3. So it's going to get brought half that distance back in to make your new figure. Notice point L did not move because it was the center of your dilation. Right? However, if we do our dilations, the ones we are going to do, it will be centered at the origin, which means all we're going to have to do is take this scale factor and multiply everything inside your matrix or all of your points by it. So 3 times 0 is 0, 3 times 5 is 15, 3 times 4 is 12, 3 times 2 is 6, 3 times -2 is -6, 3 times -1 is -3. Doing the second one, take your 4, distribute it in. We get -24, 12, 8, 20, -4, 16. And then same thing with our -3. We get 15, 3, 6, 6, 0, -12. So, there we go. The vertices of quadrilateral ABCD are given there. It says use scalar multiplication to find the image of ABCD after a dilation, center at the origin, and a scale factor of 1/3. So we're going to take that 1/3 times our polygon matrix, which would have been -3 over 0, 0 over 6, 3 over 6, and 3 over 3. So take your 1/3 and distribute it in. We get -1, 0, 1, 1, 0, 2, 2, 1. Right? And there's your two figures plotted out. Right? Here's an example of one of those composite transformations. So it says the vertices of triangle KLM are given there. Find the image of triangle KLM after our composition. So first we're going to do our translation. We're going to do x plus 4, y plus 2. So we're going to do that to each of our points. So K prime, we add 4 to our x, we add 2 to our y. For L prime, we add 4 to our x, we add 2 to our y. For M prime, we add 4 to our x, we add 2 to our y. Then we are going to do a dilation centered at the origin with a scale factor of 2. To do a scale factor of 2, we just multiply all of our points by 2. So we get 2, 4. For K double prime, for L double prime, we get 4, 6. And for M double prime, we get 6, 2. Right? And there you see we go from our original do our first transformation, and then we get our second transformation after it. All right, couple more. It says the vertices of triangle RST are given there. It says use scalar multiplication to find the coordinates of triangle R prime, S prime, T prime. After your dilation, center at the origin, scale factor of 2. So to do your scale factor of 2, we talked about we just multiply everything by 2. So R prime is -8, 6. S prime is -2, -4. And T prime is 4, 2. Right. Next it says the segment of the endpoints, or the segment has the endpoints C, which is -2, 2, and D, which is 2, 2. It says find the image of CD after a 90-degree rotation about the origin, followed by your dilation with its center at the origin and a scale factor of 2. So your 90-degree rotation, remember, if you are rotating 90 degrees and they do not specify, the assumption is we are going counterclockwise. So for C prime, we're going to flip them and change the sign of the new X. For D prime, we're going to flip them, change the sign of the new X. Then we do a dilation with a scale factor of 2. So for C double prime, it's -4, -4. And for D double prime, it is -4, 4. Last example here. Oh, sorry, that was the last example there. All right, so your homework tonight, that's pages 629 to 630, numbers 3 to 6, and 15 to 23.